Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing the fundamental counting principle, which is a topic you absolutely have to know in order to perform your best on the Armed Services Vocational Aptitude Battery. That is the ASVAB. More specifically, I'm going to break down this video into two parts. In the first part of the video, we're going to review what the fundamental counting principle is. And then in the second half of this video, I'm going to work out some questions that should closely mirror what you may see on the ASVAB. As always, I strongly recommend that you attempt to work out all the practice problems in this video on your own. That is to say, when I read a practice problem, you should pause the video, attempt to work it out on your own, and then resume playing the video. So let me just stress this. Initially, this topic's going to seem confusing, but once you get the hang of it, these problems are going to take you about 10 seconds to work out. So just stick with me with the explanation, and once we get to the practice, you're going to see that there's really nothing to the fundamental counting principle. So all that being said, let's get started with today's video. All right, so not surprisingly, I'm going to start today's video by reviewing the definition of the fundamental counting principle. And as you can see, it says the fundamental counting principle is a method used to calculate the total number of outcomes when two or more events are occurring together. The principle states that the total number of outcomes of two or more independent events is the product of the number of outcomes for each individual event. So, in the next three examples, we're going to see different instances in which we could use the fundamental counting principle to solve what otherwise might be pretty complicated problems. So let's go ahead and take a look at our first example. Our first example says, at a private high school, students must adhere to a strict dress code. Specifically, they are only permitted to wear 2 different colors of shirts and 3 different colors of pants to school. Otherwise, they'll be sent home immediately. Given these restrictions, how many different outfits can they make? All right, so generally, people would solve this problem by creating a little tree diagram rather than using the fundamental counting principle. So let's go ahead and see what that would look like. Again, if we were to make a tree diagram to answer this one, we would say, well, as far as shirts go, they can wear a white or a gray shirt. And then in addition to doing that, they would say, well, if you wear a white shirt, you can wear black pants, you can wear khaki pants, or you can wear navy pants. And likewise, they would say, well, if you wear a gray shirt, you can again wear black pants, khaki pants, or navy pants. So in total, you can make 6 different outfits. Again, there's one here that is a white shirt and black pants. Second one here, white shirt, khaki pants. A third one here, white shirt and navy pants. A fourth one here, notably a gray shirt and black pants. A fifth outfit here, notably a gray shirt and khaki pants. And a sixth outfit here, notably a gray shirt and navy pants. All right, so let me stress this. This is the long and tedious way to solve these types of problems. And as you can imagine, if this question was slightly more complicated, it would take us forever to make a tree diagram. Beyond that, when something's very tedious to do, your chances of making a mistake go up exponentially. So let's take this question again, and let's try to apply the fundamental counting principle to solve it. All right, and I'm going to break down the fundamental counting principle so that it applies to our question here, notably a question involving 2 events. So again, let's take a look at this. It says, according to the fundamental counting principle, if there are A ways of doing one event and B ways of doing another event, then there are A times B possible ways to perform both of these events together. All right, same question. Again, at a private high school, students must adhere to a strict dress code. Specifically, they are only permitted to wear 2 different colors of shirts and 3 different colors of pants to school. Otherwise, they'll be sent home. Given these restrictions, how many different outfits can they make? So in this case, we have 2 different events. Again, we have this first event, which is the color of the shirt that they can wear. And as far as the color of the shirt they can wear goes, they can wear 2 different colors, okay? And again, fundamental counting principle says if there's A ways of doing one event and B ways of doing another event, you can find the total possible ways by multiplying those together. So we're going to go ahead and put multiplication here. Let's identify our second event. That's the color of pants that they can wear. And if we reread our question, we can see it says they can wear 3 different colors of pants. So we'll put 3 in our box right here. 2 times 3 is 6. So in other words, they can make 6 possible outfits given these restrictions. Again, once you get good at breaking down word problems and using the fundamental counting principle, these questions will take you about 10 seconds to solve, including some very complicated questions. So let's go ahead and take a look at a slightly more challenging question. All right, so if you recall the definition of the fundamental counting principle, you'd realize that it said that it applied to 2 or more events. So at this point, you might not be too confident in using the fundamental counting principle. So let's take a look at another example. And again, I'm going to work this one out first using a tree diagram, which again is very slow, error prone, and inefficient. And then we'll apply the fundamental counting principle to solve it very quickly. But that said, as I mentioned, we're going to be working with 3 events in this case. So let's break down the fundamental counting principle such that it applies to this. And it says if you have A ways of doing event 1, B ways of doing event 2, and C ways of doing event 3, then you can find the total number of outcomes by multiplying A by B by C. All right, so let's look at example 2 now. Example 2 says a new restaurant has opened and they offer lunch combos for $5. With the combo meal, you get 1 sandwich, 1 side, and 1 drink. The choices are below. What is the total number of different choices for a lunch combo? So let's use a tree diagram to solve this one. And again, I do not recommend that you use a tree diagram on the ASVAB. It's too slow and inefficient. That said, let's go ahead and make ours. As far as sandwiches go, we have 3 choices, notably chicken, turkey, and a cheese sandwich. If we get a chicken sandwich, we have 3 options for sides. Notably, we can have chips, we can have fries, or we can have fruit. And this applies to all 3 sandwiches. So if we have a turkey sandwich, we can have chips, we can have fries, or we could have fruit as our sides. And then finally, if we have a cheese sandwich, we can have chips, fries, or fruit as sides. All right, so again, we know that we can also have soda or water as a drink. So again, if we have a chicken sandwich with chips, we can have either soda or water. If we have a chicken sandwich with fries, we can have soda or water to drink. And if we have a chicken sandwich with fruit as a side, again, we can have soda or water. And this is going to apply to all of these different options. If we have a turkey sandwich with chips, we can have soda or water. If we have a turkey sandwich with fries, we can have soda or water. If we have a turkey sandwich with fruit, we can have soda or water. And let's go ahead and finish this. If we have a cheese sandwich with chips, we can have soda or water. If we have a cheese sandwich with fries, we can have soda or water. And if we have fruit with the cheese sandwich, we can have soda or water to drink. So let's find out how many different options that is. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 different options. Again, you can see how complicated these tree diagrams get. And there's a big chance that if you make a tree diagram on the ASVAB, you're going to make a mistake, and it takes you a very long time to do this. But again, let's go ahead and apply the fundamental counting principle here. And let's take a look at that one more time. Again, A ways of doing event 1. Well, what's event 1 here? It's our type of sandwich. So event 1 is our type of sandwich. How many different types of sandwiches can we have? We can have chicken, turkey, or cheese. So there's 3 options there. What's event 2? That's going to be our side. So we're going to multiply this by the number of sides we can have. As far as the number of sides go, we can either have chips, fries, or fruit. So that's also 3 different ways of having sides. And then finally, as far as event 3 goes, that's going to be drinks. And again, we can see that there are only 2 options for drinks. There's 2 ways of having your drink. So this becomes 3 times 3 times 2. Well, 3 times 3 is 9, so this becomes 9 times 2. 9 times 2 is 18. All right, so again, you can either make your tree diagram, which gets really confusing and tedious and a lot of work, or you can simply take your events, identify them, identify how many options there are for each event, and then multiply those by each other. And that's all there is to it. Again, sandwiches is our event, 3 options. So 3 sides was our event, 3 options. Drinks was our event, 2 options. 3 times 3 times 2, 18. Done. All right, so as I've stressed already, you can apply the fundamental counting principle to more than just 2 events. In fact, you can apply it all the way up to n number of events, where n means however many the question has. All right, so let's take a look at an example where we have more than 3 events, and we're just going to solve this one using the fundamental counting principle, because again, if I were to make a tree diagram to solve this one, it would take me forever, and I'd probably make a mistake. All right, so let's take a look at example 3 now. It says a men's department store sells 3 different suit jackets, 6 different shirts, 8 different ties, 4 different pairs of pants. How many different suits consisting of a jacket, shirt, tie, and pants are possible? All right, so rather than making a tree diagram, which would take me forever and I'd probably make a mistake while I did it, let's apply the fundamental counting principle. And again, that says identify your events, figure out how many options there are in each event, and then multiply all those together. So this question tells us our events. One event is the type of jacket, the other event is the type of shirt, another event is the type of tie, and the 4th event is the type of pants. So I'm going to make a little box diagram to help us work through this one. So again, event 1 was our jacket. And as far as jackets go, how many different options did we have? Well, according to the problem, we had 3 different suit jackets. So again, that's going to be 3 here. We know our next event is the type of shirt that we can wear. So that's going to be shirt. And let's read through the problem again to figure out how many different shirts we had to choose from. There were 6 different shirts, so we're going to put 6 in this box here. As far as ties go, how many options did we have? According to the problem, we had 8 options. And then finally, as far as pants went, we had, where's it at? 4 options. All right, so to figure out how many different suits we can make, consisting of 3 different jackets, 6 different shirts, 8 different ties, and 4 different pants, we just multiply 3 by 6 by 8 by 4. So let's go ahead and do that. And again, if it's helpful, we can get rid of these boxes now. This becomes 3 times 6 times 8 times 4. And I'm just going to do this. I'm going to do 3 times 6 is 18. And then 8 times 4 is 32, of course. And I'm going to work this off to the side so I don't make any mistakes here. We have 32 times 18. 2 times 8 is 16. Drop down a 6, carry a 1. 3 times 8 is 24, plus 1 is 25. Now that we're starting multiplication with this 1, we want to bring in a 0 placeholder. 1 times 2 is 2. 3 times 1 is 3. Let's add these together. 6 plus 0 is 6. 5 plus 2 is 7. And 3 plus 2 is 5. So we can see that 18 times 32 is 576, which means that there are 576 different types of suits that you can make given these options. Okay, again, imagine making a tree diagram that has 576 different options in it. It would take you forever. You would only work on that question for the entirety of the ASVAB. So know the fundamental counting principle. Again, identify your events, figure out how many options there are for that event, and then just multiply that all together. So now that we've seen all these examples, let's go ahead and take a look at some ASVAB practice questions. All right, so with our knowledge of the fundamental counting principle in mind, let's go ahead and tackle some of these practice questions. Again, at this point, it's appropriate to pause the video, attempt to work out the question on your own, and then resume playing the video to check your solution. This first question, as we can see, says at an ice cream shop, they have 5 different flavors of ice cream and 4 different toppings. If you get to pick one flavor of ice cream and one topping, how many choices do you have? So again, according to the fundamental counting principle, we take our events, we figure out how many options there are within each event, and then we multiply those number of options together. So here we have flavors. That's one of our events. As far as flavors go, there are 5 different flavors to pick from, and then we're going to multiply that by toppings. And of course, there are 4 different toppings. 5 times 4 is 20. So you have, in this case, 20 different choices. All right, and there's really nothing more to it than that. Number 2 says, how many different outfits can you make with 3 coats, 5 pants, 7 shirts, and 4 ties? Again, we're going to use the fundamental counting principle in this case. And that says, identify your events, figure out how many options there are in each event, and then multiply all those options together. So as far as coats go, we have 3 different options. As far as pants go, there's 5 different options. As far as shirts go, there are 7 different options. And as far as ties go, there are 4 different options. By multiplying all these together, we'll figure out how many different outfits we can make. 3 times 5 is 15, of course. 7 times 4 is 28. And so as not to make a mistake here, I'm going to work this off to the side. We have 28 times 15. 8 times 5 is 40, so we're going to drop down a 0 and carry a 4. 2 times 5 is 10, plus 4 is 14. Before we start multiplication with this second term down here, we have to bring in a 0 placeholder. 1 times 8 is 8. 2 times 1 is 2. Let's add these together. 0 plus 0 is 0. 4 plus 8, that's 8, 9, 10, 11, 12. So we're going to drop down a 2, carry a 1. 1 plus 1 is 2. 2 plus 2 is 4. So given 3 different coats, 5 different pants, 7 different shirts, and 4 different ties, you can make 420 different outfits. All right, so that's that one. All right, so number 3 says, at We Rip You Off car dealership, a particular model comes in 4 different trim levels, 5 different colors, and 3 different interiors. How many different versions of this car model can be created from these options? So again, we're going to take our options for each of these different events and multiply them together. Again, we have 4 different trim levels, 5 different colors, and 3 different interiors. So in total, there are going to be 4 times 5 times 3 different versions of this car model. 4 times 5 is 20. This is 20 times 3. 20 times 3 is 60. So given 4 different trim levels, 5 different colors, and 3 different interiors, you can make 60 different versions of this model of car. All right, so let's move on to number 4 now. It says, at Papa John's, you are deciding on what you want for dinner. They offer pizzas with 8 different meats, 4 different cheeses, 3 different crusts, and 2 different sauces. If you get to pick one of each, how many different pizzas do you have to choose from? All right, so again, we're just going to identify our options and multiply all those options together. So we have 8 different types of meats, 4 different types of cheeses, 3 different types of crusts, and 2 different sauces. 8 times 4, of course, is 32. 3 times 2 is 6. And so as not to make any mistakes, I'm going to work this off to the side. We have 32 times 6 here. 2 times 6 is 12. Carry a 1. 3 times 6 is 18. Plus 1 is 19. So in total, if you get a pick from 8 different meats, 4 different cheeses, 3 different crust types, and 2 different sauces, you could make 192 different pizzas. All right, so that's it for this video. Admittedly, nothing was too challenging. And again, nothing's going to be that challenging on the ASVAB. In reality, it's a test of math that ranges from 3rd grade to about 10th grade. And this is one of those topics that's covered in those grades. If you found my content helpful, please consider subscribing to my channel. As always, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and catch you loose. Konnichiwa.